Okay, here we're going to do a review video about standard A2C, which is about writing linear equations given tables, graphs, or verbal descriptions. And so our first problem is this one. It says researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier has a thickness of approximately 450 meters when it was first discovered. Okay. The thickness of the ice shelf decreased at an average rate of 0.6 meters per day. Which function can be used to find the thickness of the ice shelf in meters x days since the discovery? Well, when I look at my equations, I guess these don't really follow that form, but A and C both follow the form of y equals mx plus b. Okay? They have a y-intercept, a b value, and then an m value or a slope. What this problem tells us is that 450 is the thickness when it was first discovered. In other words, that's your starting value. That's going to be your y-intercept. Your y-intercept is going to be that 450 because it's like the initial amount. And then it says the thickness of the ice shelf is decreasing at a rate. When you see the word rate, I ought to be thinking slope of 0.06 meters per day. So we have our y-intercept, that's 0.450. Our slope is going to go next to m. And so you're pretty much down to either A or C. And so you got to think about what the difference is. This shows our rate being positive, that it's increasing, that it's growing. This shows that our rate is negative or that it's decreasing. And that's the case that's happening. It says the thickness of the ice shelf is decreasing. That means going down. That's why our slope is negative. Our answer there is A. Okay, this question 50, it says the table provides some points of a linear function, so that's always helpful. It tells us that it's linear. We don't have to guess about that. And then it gives us our table and says which equation represents the same relationship. Well, when I'm going to look at my answer choices first, and I notice that they're all in a certain form. They are not in y equals mx plus b form, so I shouldn't try to write an equation in slope-intercept form. All these equations are in what's called point-slope form. And that's what point-slope form looks like, where m is the slope, and then x1, y1, that's going to be a point on the line. And so I'm looking at this, and I see that two of my equations have a slope of 1/12, because remember the slope's the number that's just outside the parentheses. But two of my equations have a slope of positive 12. So let's calculate the slope first, and then we can at least get it down to a 50-50. So I can pick any 2 points. I'll just pick these 2 points. And these are my x values over here, and these are my y values over here. And so in order to find slope, I know that our little formula for that, and is on your formula chart, is y2 minus y1 over x2 minus x1. Well, y2 minus y1 would be negative 40 minus a negative 124, don't lose that sign, over x2 minus x1, which is a negative 8. Well, when you're subtracting a negative, that just means you're adding a positive. So I have negative 40 plus 124 and negative 1 plus 8. That's going to be 84 over 7, and 84 over 7 simplifies to 12. So I know that my slope is 12. If you got 1/12 for your slope, that means you probably did change in x over change in y. You have your slope backwards. Remember, in this slope formula, we've got to put our y's in the numerator. So now I'm looking at these points, and we really have to figure out what goes where. And I know in my slope formula, it's y minus the y coordinate and x minus the x coordinate. That means that y goes on the left side of the equation and x goes on the right side of the equation. Well, if I pick the point, it looks like they use a point involving 20 and 268. They're using that point right there. So if I said y minus y1 equals our slope times x minus x1, all I've got to do is change those signs because subtracting a negative is the same thing as adding. So our equation finally, after all that work, is y plus 268 equals 12 times x plus 20. That means our answer is going to be H. Now look at this problem. The table represents some points on the graph of a linear function. We've got our table up here and says which function represents the same relationships. We've got these equations. Now these equations are all in slope-intercept form. Unlike the last question where they were in point slope, these are all in slope-intercept form. So I'm just going to find the slope, and then I'm going to find the y-intercept. Okay? And so, in order to find the slope, we're going to do our same deal as we did on the last problem. I'll pick any two random points. It doesn't matter which one. But I'm going to do y2 minus y1 over x2 minus x1. You got to be careful with your signs. So y2 minus y1, and this is to find the slope, over x2, which is negative 3.5, minus x1. So my numerator is negative 12. My denominator is whatever this is. I'm just going to go to my calculator with that. And remember that when I'm subtracting a negative, that means I'm adding. But negative 3.5 plus 3.5 is going to be 4. So negative 12 over 4 is negative 3. That's our slope. Well, honestly, there's only one answer choice that even has that slope. So I know that the answer is going to be A. If, by chance, you had a couple of answer choices that had a slope of negative 3, we'd do it like this. So we're pretending like we don't know the answer, but I know the slope's negative 3. And then we're just going to take a point. It doesn't matter which point. I'll take this point that's right here. I'll do it in green. And I'm going to take that x coordinate, and I'm going to substitute it in for x. And I'm going to take that y coordinate of 0 and substitute in for y, and we're going to solve. So I have that 0 equals, and I'm going to do 3 times negative 3 times negative 3.5 is going to be 10.5 plus b, and then we're just going to solve for this b because we're trying to figure out that y-intercept. So I'm going to subtract 10.5 from each side of my equation, and I would get that b is negative 10.5. And so that's how we could have calculated the y-intercept, although we didn't really need to in this case because we only had one equation that had the correct slope. Now I'm actually going to show a completely different way of doing this. If you go to your calculator, we know this question is linear, okay? So they tell us that it's linear. We've got that right there. So what I'm going to do is I've got this table of values. I'm going to go to Stat, Edit, and I don't know if you can't really see my button. Stats right there, and then I hit Enter on Edit. And then it gives me L1 values and L2 values. And I'm going to type in my x coordinates into L1 and my y coordinates into L2. So let me just do that real quick. I'll pause the video while I do that actually. Okay, so all I did was remember I hit enter, press Stat, and I hit Enter on Edit, and it took me to this screen. L1 is all my x values that you see in the table. L2 is all the y values. Just took care to type them in very neatly. Now I'm going to go back to Stat. And now I'm going to go over to Calc, and then I'm going to go down to LinReg, because we're going to perform a linear regression with this data. I hit Enter, Enter, and it tells me that, hey, this data has a slope of negative 3 and a y-intercept of negative 10.5. So that would have been another way of getting A as your answer. Last question. An organization has a monthly budget of X dollars. So X is the total budget. I'll go ahead and highlight that. I think it's important to highlight some things like that. Every month, $2,070 is spent on salaries. 1/4 of what's left is spent on monthly activities. Which function could be used to find the amount of dollars spent on monthly activities? Well, we know that every month they start with X dollars. We know that after that, they spend 2,070. So this expression would represent how much money is left after they spend that much on salaries. Then it tells you that 1/4 of what's left, remember, here's what's left, but 1/4 of that is spent on monthly activities. So if you were to take your monthly budget, subtract 2,070 and then divide by 4, that's going to represent the amount spent on monthly activities. That looks like that's going to be answer choice D.